Hello everyone, welcome to the lecture on molecular compounds for the grade 10 science at M. Robinson High School. Today, during the lecture, you guys are going to be using your lecture handout sheet to actually help you kind of to be able to write down the notes you're going to be taking during the lecture. So whenever you kind of see some yellow words, you guys are going to be putting those yellow words in the blank areas. To start off with, we're going to think back to what we've learned already. And we've learned about something called ionic compounds. What were those again? Ionic compounds were things that were both metal as well as nonmetals. And so those metals end up becoming, when they end up kind of trying to be perfect, they end up becoming an ion. And those ions are called cations. And cations are attracted to, of course, nonmetal ions, which are called anions. And when both cations as well as anions have different charges, they'll end up attracting each other. And so this attraction we call an ionic bond. Okay? So one of the important things about ionic compounds, we think about things like salt, all of those different type of ionic compounds, they're often kind of in crystal forms. And they're most of the, all of them are going to be solids. If you try melting them, they usually have a very, very high temperature before you can actually melt them. You ever tried melting salt before? Can't put it in the microwave. And if we actually put them into water, usually they can usually kind of become diluted in water. So they're very soluble in water. And if you actually try to pass electricity through that solution, they're often very good conductors. So salt water, for instance, is quite conductive. So let's kind of go over and talk about the molecular compounds. So molecular compounds are slightly different from ionic compounds. The reason why is because they don't have metals in them. They're actually two different types of nonmetals. And so they're kind of nonmetals coming together and bonding with each other. So where exactly were these nonmetals again? Right. These nonmetals were in the periodic table. They're above those stairs. You remember we talked about the stairs right there? So our nonmetals are things like our carbon, our nitrogen, oxygen, fluorine, chlorine, sulfur, phosphorus, etc. Okay? So those guys are going to be bonding together with each other. And when they actually bond with each other, instead of actually having two different types of charges, they're going to be doing a neat trick. They're actually going to be sharing their electrons. And so right there, this is an example, this is a Bohr-Rutherford diagram of two different elements where they're actually kind of sharing their electrons. So when they share their electrons, it feels like they actually have a complete set. So moving towards that, kind of the same type of state as the noble gases are in. So instead of calling these ionic bonds, we actually call these covalent bonds. So covalent kind of being sharing, and sometimes we also call them molecular bonds, and that's where we get the idea of the molecular compound. So here in your table, I want you guys to be writing down the molecular compounds are both two nonmetals, and in this case here, instead of actually just being solids, these guys are not only solids, but they're also liquids and gases. They often have a low melting point. They don't usually mix in water, and they're usually not very conductive. So if you actually wanted to kind of figure out, if you had an example of a formula, and you're trying to figure out whether or not it's an ionic compound or molecular compound, I want you to be doing the following. I want you to see whether or not there's a metal or a nonmetal in that formula. If there isn't a metal formula, that means that we're probably looking at basically our molecular compound, or sometimes we also call them covalent compounds. If there is a metal in that formula, let's say it's Na, right? NaCl, so Na's being one of our metals, we know that this molecule is either ionic, right? If there's only if there's two elements, it's an ionic compound. But if there's actually more than one element, right, if you remember we end up having kind of other elements in there, we probably have a polyatomic, one of your polyatomic molecules. So examples of molecular compounds, so these are compounds without ions, would be something like methane. That's the gas that's produced often in swamps or in farts, and it's also a very important greenhouse gas. This one here is carbon dioxide. You guys are familiar with that. It's another gas that is up in our atmosphere. And this one here is boron trichloride. So guys remember kind of doing a lot of these different molecular compounds when we were playing with the molecular models. So water is a great example of a molecular compound. So you guys are going to be moving on to page 2. Water is basically, there are two different hydrogens, and they're sharing an electron together with oxygen. Okay, so basically oxygen has 6 electrons on its outer shell, which we call valence electrons. It wants to be able to gain 2 electrons. So it shares one of these electrons together with the hydrogen. Hydrogen will then actually kind of feel like it's full as well, because it's going to feel more like helium because now it's got 2 valence electrons on the outside. So basically, by sharing, they kind of feel like they're actually complete, they have completed shells. So again, remember that these type of bonds we call covalent bonds. If we want to actually do a Lewis dot diagram for a molecular compound, I'm going to show you guys how to actually do this. So we're going to use this example here of our carbon fluoride. And with this carbon tetrafluoride, we're going to be using the first element, so our carbon, and we're going to be putting it into the middle. Here, this is the Lewis dot diagram, or here's one of these diagrams that we actually drew before, the stick diagrams that we drew before when we were doing the molecular compounds, the models. So with this, we're going to be kind of having our carbon. Our carbon has 4 electrons in its valence shell, and it's going to be sharing one of its electrons together with the fluorines. So fluorine normally has a total of 7 electrons on the outside. Now it's actually kind of sharing one of its electrons together with the carbon. And so basically, all together, everyone kind of feels like they're following the octet rule. So here's the other the other electron that's being shared. Right, there's another one, and there's the other one. So this is what the Lewis dot diagram looks like. You can also make it a lot more simple, and you can draw it like this. There's the carbon in the middle. There's our fluorines on the outside. And then their fluorines have their electrons all around the outside here too. There we go. This one kind of messed up. There we go. So this is a more simpler form than this. This is one of our Lewis dot diagrams right there. And when we are dealing with molecular models, we also looked at what we call double bonds. And double bonds is when there's actually sharing of more than one electron. And so this is a case here of this where we end up having 2 different carbons, and these 2 different carbons are actually going to be sharing 2 electrons. And so this is what it kind of looks like. You guys remember back to our molecular models, this is what a double bond actually looks like. It's 2 of these electrons being shared together. Okay, so let's go to the part where we talk about naming our molecular compounds. We have 2 different examples, and you guys are very familiar with this one. This is carbon dioxide, right? And you're probably also familiar with something called carbon monoxide, and I'm going to be talking about that too. And we have this is called dinitrogen tetraoxide, and we're going to try to figure out what the formulas are for these 2. First of all, we're going to be looking at, we end up looking at the first element. So in this case here, it's carbon, and in this case here, it's nitrogen. And we're going to be using those for the first part of the name of our molecular compound. Then we are going to be dealing with something slightly different. This is different from when we are actually looking at the ionic compounds. We end up using these things called prefixes. So prefixes are words that go before another word. So in the case here, when we end up looking at this sort of carbon dioxide, our carbon, there isn't another, what we call it, basically the subtype, the subscript number down here. And so we know there is only one carbon in here. And so one will end up having the prefix of mono. And in this case here for our nitrogen, we look at the subscript number, and there's a 2. So 2 is di. And you guys will notice that if you turn to page 3, I actually have a chart for you guys here of all of the different prefix numbers. So these are important. If you guys don't kind of know your prefix numbers, you may want to kind of review them, write them down. I'll also try to make sure I kind of I'll put them somewhere around so it'll help you guys during a test, etc. So when we look at the prefix number by looking at the subscript number, as I mentioned, there is only one carbon, so it is mono, right? And with the nitrogen, there's 2, so there's going to be di. And the case here with mono, when we actually kind of write out the names, if there's only one atom of that element within the compound, we usually don't put mono at the beginning of the name, right? So it's not like mono dioxide, right? It's carbon dioxide. So mono is never used at the beginning. But if there's actually only kind of one atom of the element for basically at the back, then we actually end up using the word mono. But I'll talk about that again when I talk about mono, so carbon monoxide. So here we've got, for our second element, we look at the name right there. It's oxygen, okay? And here again, it's oxygen as well, but we're going to be looking at the subscript, okay? And we end up having, instead of calling it oxygen, the same thing we end up using, the second element is always going to have the I, just like we did with ionic compounds. And we end up looking at the subscript number. So there's 2 of them. So 2 is di. And here there's 4. So we kind of go back to looking at our chart. And we know that, according to our chart, 4 is tetra. So let's put both of these together and come out with a full name. So here, this is carbon. That was our first element. And of course, even though there's one, we never use the word mono. And then we have our oxygen, or oxide. Since there's 2, we'll end up putting the word di, our prefix di. In the case here of our nitrogen, we have our nitrogen back there. Ooh, you look at that. There's a misspelling right there. So nitrogen, since there's 2 of them, we've kind of put the prefix right there of di. And our oxygen has now become the oxide, just like we did with their ionic compounds. We've got the 4 right there, so we're going to be putting in the word tetra. So when I look at these words, I have carbon dioxide. I know that there's no prefix here at the beginning, so therefore there's only going to be one carbon. There's only one carbon. And dioxide, I know that there's going to be 2 oxygens. 2 oxygens right here, carbon dioxide. Dinitrogen, there's 2 nitrogens. Tetraoxide, there's 4 because I've got tetra, and there are 4 oxygens right there. What happens if I had CO2? Sorry, not CO2, but CO. And this is carbon monoxide. Okay. In this case here, just like what I did here for the carbon dioxide, since there's only one, I never use the word mono in front of it. But for the second part, right there, there's only one atom of the oxygen. I'll definitely end up using the prefix mono. This is the only case where you actually will be using the mono prefix. It's only on the second element or the second atom. Okay, some of the kind of more common compounds that you may know about are things like water, right? We never call it, what would actually water be if we end up kind of calling it by its proper name? So there's two right there. So we end up having the word two would be di, and this is dihydrogen. And of course, there's only one oxygen, so we would call it monoxide. So if you ever want to kind of trick your friends today, you can say, this is very tasty dihydrogen monoxide. And they're going to be like, what are you exactly drinking? Right? This is the problem where a lot of people are very afraid of kind of chemical names. But if you say dihydrogen monoxide, all it is water. There's other kind of compounds that we actually don't, since they're kind of common compounds, we actually don't use their, I guess, kind of their fancy chemical names. Things like ammonia. And this one here, this is peroxide. So this is kind of a very familiar compound if you're ever actually in the cosmetology program. That's what we use for dyeing hair. So let's do the reverse, where we actually have the name, and now we actually have to put it into the formula. So you guys want to make sure that you're here on the third page. I'm going to be working through that. And we're going to use that dinitrogen tetraoxide like we actually looked at before. So we end up looking at, on our periodic table, our nitrogen, right? So we have our N, and our oxide was our oxygen. Then we're going to be looking at the prefixes. So we know that di is 2, and our tetra is 4. And now we're actually going to be putting into the chemical formula. So there's our nitrogen, and there's 2, and our oxide is our oxygen, and since it was tetra, it is now 4. So it's kind of reversing it. It's a lot more simpler than having to deal with that crisscross rule that we did with the ionic compounds. So there we go. Now you've actually kind of learned how to be able to deal with both the name and the formula of our molecular compounds. Next lecture, you're going to be learning about something we call the diatomic compounds, and they're very much like molecular compounds because they're going to be two non-metals, but they're very unique. And you guys actually made some molecular models of these too. So I'll hope you guys enjoy this, and I want you guys to continue on working on the different kind of questions that go together with this lecture sheet. Okay? See you guys in the next lecture.